Chapter 11, Areas of Polygons. Today we're going to cover Section 11-8, Geometric Probability. Objectives. Use areas to solve problems involving geometric probability. And the one thing I want to remember here is that probability is the number of times an event occurs divided by the total number of possible outcomes. So problem 1. If AB equals BE equals EF and BC equals CD equals DE, what's the probability that a point selected at random is between B and C and between C and F? So the first thing I'd like to look at is sort of this part right here, that BC, CD, and DE are all the same size. So if I look at them on the number line, all of those should be congruent. So I'm going to give them numerical values and just say they're all a distance of 1. Well, the next thing I notice is that AB, BE, and EF are all the same size. Well, if I look at the number line currently, BE is totally 3, so AB is 3, EF should also be 3. So if I now go through the probabilities, so what's the probability that a point is randomly between B and C? I'm going to put probability that it's between B and C. Well, that probability is going to be the fraction of what's the area, or in this case, what's the distance between B and C? Well, from B to C is a total distance of 1, and what's the length of the entire number line? So if I add up all the values on the number line, the grand total is 9. So the probability that it's between B and C is 1 out of 9. Well, now let's look at the probability for the next part. So what's the probability that it's between C and F? And again, it's going to be a fraction. And if I look at the distance from C to F, well, the distance from C to F is a total of 5. Out of a grand total for the entire number line is 9, and that doesn't reduce. So the probability that a point randomly is chosen is between C and F will be 5/9. Number 2. A different commuter train stops at a certain train station every 20 minutes. The length of time each train stands at rest at the station is 3 minutes. So I want to start by actually just drawing in, what does this look like? So let's make a number line. And I know that the entire time of the visit is a grand total of 20 minutes. And the train is only there for 3 of those minutes. So I'm going to assume that the train got there right at the beginning. So for 3 minutes, the train is sitting there, and the other 17 minutes the train is gone. So for part A, it says, if you arrive at a random time, what's the probability that you will be able to board the train as soon as you arrive at the station? So what's the probability that the train is there? Well, the probability is 3 minutes the train is there. Out of every 20 minutes, 3 over 20 doesn't reduce, so there's your final probability. Part B. If you arrive at the station and there is no train waiting, what is the probability that your wait will not exceed 10 minutes? So this changes a little bit. So I want, what's the probability of no train and wait less than 10 minutes? So if you get there and the train is not there, I'm really only looking at this portion out here at the end, where I know this portion is made up of 17 minutes. Okay. So you're in that region, the train is not there. And if you want to wait for, it doesn't exceed 10 minutes, it must mean that you're right at the last 10 minutes of this wait. Because the last 10 minutes of the wait, you wouldn't have to wait for more than 10 minutes, and then the next train will automatically be there. So what's the probability of there's no train and your wait is less than 10 minutes? Well, that's 10 minutes worth of time out of 17 minutes, and the probability is 10 out of 17. Number 3, darts are to be randomly thrown at the dartboard to the right. Part A, what's the probability that the dart will land in the triangle? So if I figure this out, I'm really trying to find what's the probability that the dart is inside of the triangle. Well, to figure that out, I want to know what's the area of the triangle. And I know that the area of a triangle is 1/2 base times height. So it's 1/2 times the base of 3 times a height of 2, which is going to give me an area of 3. And the total would be, what's the area of the rectangle? And the rectangle is going to be 12 times 6. And 12 times 6 is 72. And now I just reduce between 3 and 72. 3 goes into 3 once, and 3 goes into 72 24 times. So the probability of throwing a dart and having it land in the triangle is 1 to 24. Part B, what's the probability that the dart will not land in the circle? So, probability not in the circle. Well, if I think about, I want the area that's not in the circle, so that's really going to be the rectangle minus the circle, and divided by the total, which would be the rectangle. Well, up above, I already figured out that the area of the rectangle was base times height 12 times 6, which is 72, minus, now we need to find what the area of the circle is. And I know the area of a circle is pi times the radius squared. And in this case, I know the radius is 2, so that's really going to be 2 squared is 4, and I get 4 pi. So when I come back to my formula, I'm taking the rectangle minus the area of a circle and dividing it by the total area, which was the rectangle, which was 72. And now I'm just going to reduce. So if I look at reducing, I'm going to reduce between 72, 4, and 72, and they all happen to be divisible by 4. So if I divide by 4, I get 18 minus pi all over 18. Or if you split this into 2 separate fractions, you could get 18 over 18 minus pi over 18, which is 1 minus pi over 18.